So let's start with the what we call it from the story of the PLS-SEM. That where did the story start, and why this PLS-SEM was introduced. So in fact, you know that uh, back in more than 100 years, the SCM, the thing structural equation modeling, uh, the people started using it. So it's not something very new that we are talking about, but obviously the way now we are using is it's new and it hasn't been used. So the story begins from the time that when there was the idea, or when there was a problem to measure or to gauge the abstract variables. Means there were behavioral variables, and psychiatrist was used to gauge those variables, to operationalize those variables, and it was harder for them. For example, the intensity of happiness, or the extent of maybe motivation, or sometimes the tendency to suicide or tendency to live. So these were kind of the questions which were posed to the psychiatrist, and they were keen to gauge, or they were keen to operationalize and quantify this phenomenon. So at that time, obviously, these are the phenomena which are unobserved. These are the latent phenomena which cannot be seen, and we cannot find any kind of a hard data. Like, for example, we find the data of GDP, inflation, or the prices and all that. So that's why the uh, psychiatrists tried to develop a certain set of questions, and those set of questions were asked in order to quantify or operationalize that particular construct or that abstract concept. For example, if they were talking, if they wanted to know about the happiness, level of happiness of a person, so they had a certain questions about his or her quality of life and about other things. And then on the basis, cumulative response of that, those items or those questions were used to consider or operationalize as that particular variable. So that's why it was called as a psychometric analysis. It was, if you just see the initial days of this construct, or the latent variables development, that was called the psychometric analysis. So that variable which was unobserved and which was gauged by the various items, that variable was called construct normally, and it was also named as unobserved variable or the latent variable. So whenever we see, we hear about unobserved or latent variable, or what we call it, maybe the abstract variable. So it means that we are talking about a behavioral variable or any of the variable which cannot be directly measured through data. So that was in fact the start of this word constructing. So that the construct started developing from that psychometrics property. Now the problem was that obviously once you're asking questions in order to cumulatively represent and gauge a construct or a phenomenon, it was very important to know that whatever questions are being asked, those questions are truly representing the phenomenon which is aimed to gauge, and those questions are being rightly understood by every participant of that particular population, or to whom these questions were being asked. So for that, the reliability and the validity of that construct, that thing started happening again back 100 years back. So what psychiatrists used to do was they were having the set of questions which were obviously drawn from the theory, and those set of questions were asked. And later on, once after getting the data, the reliability and the validity was checked, and then whatever the results were, those results were used to see the extent of that variables in the people. So that was the start of the constructing, or which we call it the psychometric properties. After that, once we have, for example, gauge the phenomenon, and then we want to check the impact of one variable on the other. So then they used to plug in the regression analysis. First, the variable was gauged, then reliability and validity was tested, and that the whole process was named as the confirmatory factor analysis. So again, the CF is also not a new thing. It was done back 100 years before. So when the questions were asked, and in order to see the reliability and validity of those items, that those items or the questions are truly representing the phenomenon which is being aiming to gauge, and those questions are being truly understood by the every member of the population. So that to do that, that was labeled as a confirmatory factor analysis. So once first they were doing the confirmatory factor analysis, and then after that, in order to see the impact of one variable on others, the regression analysis was done. So it was a two-step procedure for the in order to check the analysis of the one abstract variable on others. That first the CFA was used to be done, and then there was the regression analysis were being in place. And then again there were a problem was that if there is a complex relationship, means that if, for example, variable A is affecting B, for example, the tendency to spend is affecting our living standard, and living standard is, for example, further affecting our happiness toward life. So the living standard is a variable which was a kind of a mediator. It was first being affected by the spending, and then it was affecting the life. So that kind of complex variables are, if we were developing, if there were the more complex models, it was not easier to estimate in the regression analysis. They were, that many equations were used to develop. So once the people started facing the problem that first to do CFA and then regression analysis and then modeling complex relationships, there was a big problem. So then the concept of the structural equation modeling came into being. So what the structural equation modeling did, first of all, it combined the confirmatory factor analysis and regression analysis into a one set of, that approach. Secondly, it was comprehensive enough to accommodate the complex relationships. For example, the mediation, moderation, and serial mediation, and all that, which will be later on we'll be discussing. So, and the more interesting and the good thing was that these things normally was used to be done through the regression and econometrical equations. So the structural equation modeling came with the very kind of user-friendly graphical interface through which there was not required to develop any kind of equations. Rather than we could simply connect our variables with the arrows, our framework, the way we develop the framework, the same framework could be developed in the software, and then we could run the analysis. Earlier days, it was only SEM, which we call structural equation modeling, and then it got into what I say that two major school of thoughts. There was a one covariance-based SEM, and the other one was the PLS, or the partial least square based structural equation modeling. In fact, covariance-based SEM, which was popular in the initial days, and it remained popular until even back in 2010 or 2013, this approach was considered as a very stringent, and this was primarily based upon the maximum likelihood estimation method, which is used in the econometrics, and was considered, robust in terms of whatever the relationships have been identified by the CBSEM. Those were the true relationships. Whereas the PLS-SEM was considered as a soft modeling approach, and the higher tendency of the experts were toward the CBSEM. However, later on in the 2010, the people like Joseph Hare and Ringel and Satterwort, these people came, they in fact restudied the concept of the partial least square structural equation modeling, and then they came up with the empirical evidences that PLS-SEM is equally robust as the covariance-based SEM is. Secondly, they in fact presented with the help of a lot of empirical evidence that PLS-SEM is as compared to the CBSEM. So